Do you remember when you first started to discover how the world works, how ice melts, that balls bounce, that hot food hurts your mouth, but after a while it's okay? How soap bubbles drift through the air and look just like rainbows right before they pop and vanish? How you can hear an echo in a big room, or how your shadow gets bigger the closer that you move to a lamp? All of these things are examples of how physics governs our lives. And when we're little, we see those laws of physics played out, and then we start to discover them and how we might use them to make things better, more interesting, and more fun as we play. It's in this exciting moment of discovery that when we're young, there's this incredible chance to capture that curiosity, to nourish it, to nurture it, so that it becomes a way of moving through the world, being okay with not knowing the answer to something and enjoying the discovery of why something is how it is. I remember it myself when I was young and how it set me up for a way of looking at the world. And in many ways, I credit my guests today for giving me that gift. Today, I'm speaking with two absolutely legendary science communicators, Rob Morrison and Deane Hutton. For 18 years together, they brought Australia the Curiosity Show, opening up a world of possibility to generations of Aussie kids, me being one of them. Absolute pioneers in kids' television. They assumed intelligence of their audience, and they brought complicated concepts to life with simple and practical demonstrations using just everyday household objects. They wore turtlenecks. They had great moustaches, and it all happened to the soundtrack of some excellently odd synthesizers. These guys paved the way for the megastars of science communication that we know today. Now, it's no lie, I absolutely loved the show that they made, and I was thrilled to discover that they purchased back the rights to their content so they could launch their own YouTube channel. So when Wolfgang, our youngest, asks me, why does air escape from the balloon like, I can dial up on YouTube and show him the answer exactly how I learned the answer. Now, you can enjoy the full podcast where you get your podcasts, so here's just a little bit of a taste. But before we kick off, Deane does sound different to how you might remember him, and he's actually quite open about the reasons why. Deane has Parkinson's disease, and it affects the way that he speaks and the way he moves. But don't worry, he is as sharp as ever. Enjoy just a small part of a much longer and delightful conversation with two men who open up the eyes of millions of Aussie kids to the importance and the wonder and the reverence of science. This is Rob Morrison and Deane Hutton.
We were sort of brought in on a preschooler program, and for some years we mixed it up with Humphrey Bear. That was a nightmare. But
what's the nightmare about working with Humphrey B Bear? I mean,
look,
he has no pants. Let's start from there.
Well, really, Humphrey couldn't talk, so he did everything in mime, and so he had a 3-year-old audience, 3-4-year-old audience. So in come these jolly academics, and they're after a 10 to 13-year-old audience. So Humphrey, the people inside Humphrey, there's several of them, could feel us sort of, taking their audience away, and they didn't like us. And so Humphrey would usually get behind you and upstage you by doing all this stuff behind you and mucking up your props. I think with Deane, they actually destroyed the props.
Yeah, one time I was doing a segment on insects, and I had cockroaches in a glass dish, and I showed kids how you actually pick up a cockroach with a matchstick or a toothpick with a bit of Vaseline on the end, and you touch it on the back of the insect, and then you can lift it up, turn it over, look at the segments and the antenna and the legs. And as I was doing this, Humphrey suddenly grabbed a rubber mallet, which he'd planted in the studio before the segment started, and he grabbed the mallet and started pounding these cockroaches, which were breaking legs off and flying in different directions. And the producer of the program at that time, Ian Fairweather, said, "Humphrey, you can't do that." And Humphrey, if he got angry about something, he'd pull his head off. He'd lift his head off, and this great bear suit with a little head poking out the top said, Humphrey doesn't like creepy crawlies. And so fortunately I had some spares and we redid the segment, but so that part didn't go to air.
I got my revenge. We had an outside broadcast unit, which we took out to my university, lecturing sort of university laboratory. And I set it up with all sorts of things to look good. And one of them was a Van de Graaff generator. Now, kids have these things in science fairs where you generate about 50,000 volts and you stand on something and your hair all stands on end because of electrostatic electricity. And this thing was grinding away in the background. It was new and it was a nice dry day. And Humphrey was doing his usual thing behind me, trying to put my audience off while I was talking, and started pointing at this thing. And I thought, well, this will be interesting. You don't point at a Van de Graaff generator. And he just got a bit close. And there's a crack like a pistol shot and an arc of blue fire, I swear about 1 metre long, leapt into the outstretched digit of this unhappy bear, who did a quick 360, and from the depths of this woolly suit, you just heard, which I think was the only time he spoke on television, and a most inappropriate word for his audience, but it shut him up. He didn't do that anymore.
When you both have a look at the challenges we face as a country, recently, over the last 3-6 months, AI suddenly shows up as like, we really need to talk about this. What do we need to ready ourselves with when it comes to understanding concepts of science in order to be able to process what we need to process come not only election time, but like how we shop, how we live?
It's a very big question and a very important one. I think going back to something you said earlier, I think that the building blocks of science, that's important. But it's, then you have to start saying what they are. My point too about science teaching is that it's too often just facts. It's what science has discovered, but that's not science. And any little primary child can understand a simple science experiment. You make a cake and it comes out of the oven and it's all crappy and flat and awful. Now, you don't immediately say, right, I know what we've got to do. We've got to double the sugar and triple the temperature and halve the water. You say, what's gone wrong here? The hypothesis is I didn't turn the oven on. Okay, what do? You repeat the experiment. You don't change every variable. You just change the temperature of the oven and it comes out right. Now, that's science. That's a process of science. And you can do that with the tiniest kid in the world if you say, well, what's going on here? How do we explore it? But you need the confidence to know what the process is. It's not hard, but you need to have it. And that's why so little science is taught in science. I think to have that under your belt means that you can look at advertisements. The internet is flooded with the most extraordinary nonsense about health. 5 of us formed, 10 years ago, Friends of Science in Medicine, which is really to combat some of this nonsense that's flooding the internet. But people have no ability to say, this is rubbish and that's true. They have no ability to say, well, let me be skeptical, not cynical, skeptical about this and test it against the things that I know are right. So that loss of ability is a huge one as we're flooded by the anti-vaxxers and the flat earthers. We get a lot of them on the channel. They write into, this can't be true, the earth is round, mostly from America, but not always. So that ability, which is the true essence of science, is, I think, crucial, and I think we're further away from it than we were.
I think one of the things that will come through to you again and again if you're a science communicator is that we're talking about not a subject that's a list of facts, but we're talking about a process by which we can understand the world, a process by which we can cooperate with others, a process by which we can show that through 2, 3, 4, 10 people working together are bound to produce more questions than answers. And if they produce more questions than answers, they're well on the way to using science to understand the world. And that's what we're all involved in.
When we think about a scientist, we think of someone, they're very clever and they know a lot. But actually, they're only where they are because they have spent decades going, I have no idea. I don't know, and I want to know, and being comfortable with not knowing.
I think that's true. It's true to be comfortable being not knowing. And I think that's the reason why when somebody asks a question, a student in school or some member of the family, the next door neighbour, if somebody asks you a question about why something happens or how something works, if you can respond, first of all, with more questions, you'll find that they'll find you'll be delving into the truth of the matter in a deeper way, because of the cooperation between people who are sharing questions and sharing the way they seek out answers.
And it's also some of the people who are most knowledgeable and predominant in their field are also the most dogmatic. And they'll make a pronouncement and then pride says they're not going to back it away with it. And if you look at the whole tangled question of climate science now, it's absolutely full of this. We don't seem any longer to have discussions. We have arguments. And in arguments, you say, this is my position and I'm not going to bloody well change. I'm just going to force it at you. So we're losing the ability to discuss and argue something out in a sort of give and take way. You know, I want a discussion with you about climate change. I want to know if my ideas are right or wrong or how I should modify them. In an argument, I don't want to do that. I just want to tell you what I know and you should believe. And that's greatly fostered, of course, by social media, but it's almost the hallmark of what goes for discussion these days. And cancelling then if you don't like what somebody says.
Does it come down to humility, Rob?
Well, it comes down as lots of things. I mean, humility is perhaps there, ability to monitor yourself and say, hang on, need I go back and revise this? It comes down to reading widely. I mean, you'll read some arguments. I read the national paper. I wouldn't say my politics are probably those of most of the people who write in it, but I take some care to read the columns of the people I know have politics different from mine. Because sometimes in there, like it or not, I'll find something that makes me think, yeah, I'll give that some thought. And I do find it changes your mind. It's very hard sometimes to let go of the things that you have publicly said you think are right. It takes, I don't know if it's humility, it's part of the scientific process. You've got to be prepared to let something go if the evidence takes you in another way. And that should be a pride for scientists, not an injury to their pride. One of our Nobel Prize winners, Eccles, Sir John Eccles, had a sort of turning point in his career where he stopped doing that about the things he believed in and actually said, no, this is wrong. Let me explore this. And it completely changed the way he did his science. He got a Nobel Prize out of it.
And one thing that we all need to realise when we're seeking answers to questions is that we're almost certain to get to a position where we realise that the questions are bringing about more questions, and that if this happens, it's a good thing. It's a good thing for us to be humble about the things we've discovered, to be inquisitive about the things we are yet to understand, and to be cooperative in the way we share knowledge and share information. And by doing these things, by sharing things, knowledge and information, we're bound to help increase the amount of information and the amount of understanding that goes on between people as they seek answers to questions.